All right, kids, welcome to part 2. Now, like I said, I'm just piecing concepts together. I'm going to give you one concept at a time, and at the end I'm going to piece them together so we can ultimately find the area of a regular polygon with ease, because this becomes very complex, ultimately, but the way I'm showing you is one step at a time. And in order to find how to do the ultimate goal, now in this video, I want to show you about identifying the parts of a regular polygon and to find the vertex angle of my right angle. And you don't know what that means yet, but you will in like 2 seconds. So I'm going to just draw a regular polygon, any old one. I'll draw. Forgive me for my artwork here. So I made it's supposed to be a regular, let's see, 1, 2, 3, 4, 5. Okay, so it's a regular pentagon again. And what I want to do is show you that whenever you have a dot right there, the point, that is called the center. That's the center. It is the center. And if I draw in the line segment connecting the center to a vertex, remember, all these are vertices. That's plural for vertex. This is called a radius. And if let me zoom in on that so you can see it better. If I drop a perpendicular down from the center to the side, if I make that perpendicular line segment from the center of the regular polygon to the side, that is called an apothem. Apothem. That is the apothem. That's okay. And then also, these right here, guess what these are? They're just called the sides. They're called the sides of the polygon. Now, of course, this is a regular polygon, which means all 5 sides are congruent. Now, another thing I want to say about this right triangle. This angle right here is going to be very, very, very important. And if I take this triangle and I draw it outside of the diagram, if I draw it, say, right here, where this is the apothem, this is the radius, I'm going to call this, this side right here, this bottom right here, I'm just going to give it a name. I'm going to call it the base, just for my own purposes. This side right here, the base, where does that fit on the polygon itself? Well, right here, this half right here, this right here is the base of the right triangle. Base right there. Let me zoom in on it more so you can see it better. So when I make that triangle right here, this is the apothem, this is a radius, and I'm going to call this the base of that right triangle, just so I can give it a name. And here it is a little bit neater than my right triangle. Now remember, this point right here, that's the center. But remember, this angle is very important. That angle right there, that angle, as I'm showing you right here in this triangle, if you relate that back to the polygon, is this angle right here. It's the angle created between the apothem and the radius. And the vertex is at the center. I'm going to give that angle a name. I'm going to call it the vertex angle. The vertex angle generally, I mean, it's known to be used as, whenever they talk about a vertex angle, they talk like in a triangle, that usually refers to the angle that's way at the top. But that vertex angle right here, that's very important. And I want to tell you something very special about that vertex angle. Do you remember in the last video when I said you have a central angle created by the center and the 2 radius? When you drop the apothem down. And I'm gonna be very careful because we're coming up to the main goal of this video. Here I'm drawing this again. I'm drawing the diagram one more time so it can be seen very clearly. When you have the center, and when you have the central angle from the other video, and we said that was 72 degrees, because remember the measure of the central angle equals 360 divided by n. In this case it was 360 divided by 5, which was 72, I believe it was. Well, that whole entire angle was 72. The whole measure of that central angle was 72. But here's the deal. When you drop the vertical line from the center to the side, three things happen. Number one is perpendicular. Number two, it bisects this side of the polygon into two equal segments. But not only that, but this apothem bisects the central angle. Now remember we said the central angle in this particular case was what, 72 degrees? So if you take 72 and divide it by 2, it gives you 36. And all I'm telling you is that whole entire angle, which was 72, was bisected. So guess what? This angle is 36 degrees. And let me zoom in. And guess what this angle is? You guessed it, 36 degrees. By the angle addition postulate, if you take 36 plus 36, it gives you the central angle of 72. But our focus is, in this particular video, how do you find that vertex angle created by the apothem, which I'm highlighting, the radius, and this base right here. And this base happens to be half of the entire side of this polygon. I'm not saying it is, but just make believe this whole side was 20 from here to here. Once you draw in, let me zoom out. Once you draw in the apothem, and the apothem bisects the central angle, but it also bisects this line segment. Supposing I told you this line segment was 20, guess what this piece is right here? You guessed it, that's 10. And by the definition of bisecting, segment bisector, this is also 10, because by segment addition postulate, 10 plus 10 is 20. So if you transfer that to this triangle, you now know how to find the vertex angle, which is 36, and you now know that the base of this right triangle is half of the whole length of the side. It's right there. So that base equals half the side. Remember, if you look at your regular polygon, this is a side, that's a side, that's a side. When you find the base is nothing more than half of the entire side. And I want you to keep that in mind, that the base of our right triangle, the base, equals half of the side. And I just wrote it right there. This base is half of the side of the polygon. Again, you see here, that's the base of this right triangle, the base of that right triangle, which I'm coloring in so you can see the right triangle. That right triangle is going to come into play over and over again. And finding this vertex angle up here at the top is going to be paramount. So to sum this up, the vertex angle equals the measure of the central angle divided by 2. And if you don't remember what the vertex angle is, once you make your little right triangle, it's that top angle right here. And I'm going to need you to be able to find the vertex angle. If you could do that, you're set. Okay? Okay, so you find the measure of the central angle divided by 2. And remember, the measure of the central angle is nothing more, it's right here. It's the measure of the central angle is 360 divided by n, where n is the number of sides. Okay, I hope that helps. And we'll continue in part 3.